This presentation focuses on frequent pattern mining, which is a key task in data mining. Frequent pattern mining helps us discover patterns, relationships, and associations that occur repeatedly in large data sets. These techniques are commonly applied in areas such as market basket analysis, recommendation systems, fraud detection, and web usage analysis. The goal is to extract meaningful and actionable insight from raw transactional data. Frequent pattern mining is concerned with identifying combinations of items or events that occur frequently together. In real-world scenarios such as retail transactions, these patterns reveal customer purchasing behavior. This slide sets the foundation by introducing the key concepts that will be discussed, including item sets, association rules, and the algorithms used to efficiently mine these patterns from large data sets. A frequent item set is a collection of one or more items that appear together in a transaction database with a frequency greater than or equal to a user-defined minimum support threshold. For example, if bread and butter appear together in many shopping baskets, the item set bread butter is considered frequent. Minimum support helps eliminate rare combinations that are not useful for analysis. Closed item sets are frequent item sets that do not have any supersets with the same support value. This means they capture all the frequency information without redundancy. By focusing on closed item sets, we reduce the number of patterns while still preserving complete information, making analysis and interpretation more efficient. Association rules express relationships between items in the form of if-then statements. For example, the rule bread, butter means that customers who buy bread are likely to buy butter as well. These rules are derived from frequent item sets and help identify meaningful dependencies among items. Support measures how frequently an item set appears in the dataset. Confidence measures how often the association rule is true when the antecedent occurs. For example, if 80% of customers who buy bread also buy butter, the confidence of the rule bread butter is 80%. These metrics are essential for evaluating the usefulness of association rules. The frequent pattern mining process begins by defining a minimum support threshold. Candidate item sets are generated and their occurrence counts are calculated. Items set that do not meet the minimum support threshold are discarded. This process is repeated iteratively until no new frequent item set can be found. The a priori algorithm is a classic approach for mining frequent item sets. It follows a bottom-up strategy, starting with single items and expanding to larger item sets. A priori relies on the a priori property, which says that if an item set is frequent, then all its subsets must also be frequent. This property significantly reduces the search space. First, the algorithm identifies frequent 1 items by counting individual item frequencies. Next, it generates candidate 2 item sets from the frequent 1 item set and evaluates their support. This process continues for larger item sets until no additional frequent item sets can be generated. FP growth is an efficient alternative to a priori that avoids candidate generation. It compresses the database into a compact structure called the FP tree. The frequent item sets are mined directly from the tree using a divide and conquer approach, which makes FP growth faster and more scalable for large datasets. In the vertical data format, each item is associated with a list of transaction IDs where it appears. To compute the support of an item set, transaction ID lists are intersected. This method avoids repeated database scan and is efficient when working with large transactional datasets. After mining frequent patterns, evaluation measures are used to determine their usefulness. Lift measures how much more likely items are to occur together compared to random chance. Conversions measures the strength of implication in an association rule. These metrics provide deeper insight than support and confidence alone. Frequent pattern mining is a powerful technique for discovering relationships in large datasets. Algorithms such as a priori and FP growth provide different strategies for mining frequent item sets. Evaluation metrics such as support, confidence, lift, and conviction ensure that the discovered patterns are meaningful, reliable, and useful for decision making.